Hello and welcome to the part 8 of our course on Team Foundation Server 2010 for software developers. And today we are going to talk about such thing as automated testing, and more specifically about bugs in automated testing. So bugs are perhaps the most common and most frequent objects that you generate during the automated testing. However, there is a big difference when you're working with a quality assurance specialist who just discovered your software to malfunction, or when you are talking with your customer, and with TFS when it discovers the error and creates bug automatically. The biggest difference here is that when you're talking to a human being, you have a witness, so you can ask any questions systematically or not, it doesn't matter. You are asking him what sort of system it was, what he did, what do you need to replicate this error, and so on and so on. And as a witness, as someone who knows everything that end user knows, he can answer you that questions. Obviously, when the computer creates the bug, when the computer discovers the error, he is not able to talk to you, at least not in this version of Team Foundation Server. So, by following the logic, we could say that Team Foundation Server should record all the required information, so you would be able to retrieve that information later. And in case it doesn't store that information by default, then perhaps we should find out how to switch it on, so with every bug you would have all the required information to replicate this error and perhaps even to debug your application. And that's what we will do in this part. So this scenario is such that you are a developer and a tester mentioned a bug in your software that you have not been able to recreate locally. You will change test settings data diagnostic to gather more information to help you to recreate this bug. So we are going to record additional information with that bug and use that information in our Visual Studio to find out how it happened and what was there. And as you will see, it will be way better than if we would just interview the witness of the bug. So we will start with Test Manager, because that's where our testing plans are stored. We will just connect to required project. So it's a simple calculator project which doesn't calculate right. One of the functions doesn't work. We'll make a little pause here and take a look that we have smoke test and the multiplication test. Well, since it's a calculator, it's quite obvious what the multiplication tests are. But however, what is a smoke test? As a quality assurance specialist, you perhaps already know that term. As a developer, you will encounter the term perhaps later, maybe in a conversation of quality assurance specialist. So the smoke test basically means that It's the very first and very basic test to find out whether your software can start up. The origin of the smoke test is from plumbing. You know, the sewers, they have pipes, and the sewers specialists are required to find out whether there is a leak in that pipe. So they pushed the smoke into the pipe and see where the smoke goes out, if it goes out. So if smoke goes out somewhere and not where expected, it means that the pipe is broken and there is no need for further tests. In electronics, smoke test means that you connect your say main board to electricity, and if you see a smoke, it means that well, you don't need to run any further tests. So the smoke test in our case means that we run the application. Perhaps we don't go through all the features of it, we don't go through all the unit tests, we just run it when we close it. If it cannot run, we don't need to run any further tests. So if there are problems with build, if there are problems with some very basic functionality, the smoke test will reveal it, and it will save some time, some processing time of our lab agent, of the test agent. These agents are parts of the Team Foundation server. We'll find out it later when we will talk about the setting up the automated testing. So the smoke test is like a very good practice to include into your testing plans, so you will just not have to run all the unit tests, all the integration tests. You will not waste time if your application doesn't work. Another bonus of this is that TFS, at least by default, when you are creating, say, build definitions, there is a setting that it will create work items in case of failure, and you already know what this work item is. It's a bug. So the Team Foundation server will create a bug in case something doesn't build. It will create a bug during the testing if tests are failing. So the smoke test will allow you to create just one bug instead of creating perhaps 100 bugs for each test that fails. So we are going to Lab Center. And to the test settings. And the test settings define the, well, actually settings for tests, which contain the list of data that we need to store regarding that test. You will see it a few seconds later. So we are capturing steps to help to reproduce the bug, and we'll record the IntelliTrace. More about it later. As you can see, by default we have switched on the ASP.NET client proxy, which we don't need in this case. It's a Windows application. So we need system information, we don't need test impact, and we will need video recorder because it's much better to see once than to hear 100 times. Okay, so we recorded it, and including the IntelliTrace. And IntelliTrace is what will allow you to look at internal objects during the debug session. So the bug that will be created by Team Foundation server will contain all the information that will allow you to start debugging of that application. In case that was a sloppy explanation, you will see it in action in a minute. Now I switch to the testing center, go to the plan, and then switch to the properties. The properties of this test plan. We don't need to change anything here. You just see that the test settings now include this new settings that we created. And depending from what do you need from the particular test or the test list, you can create your own settings. So you will make sure that these tests include everything that you will need as developer. So now we are running the Ultimate Edition of Visual Studio 2010. We are connecting to our project. And this is the bug. This is the bug that contains all the information that we need. The mentioned bug created by quality assurance specialist. And as you may notice, this is a Team Foundation server work item. So we'll open it on full screen and take a look that in the lower part of this work item there are tabs like details, system info, test cases, and so on, and it includes these steps. Steps that quality assurance specialist was following, and the result of each of these steps. And the step number 4 is red and shows failed. And you will also notice now under the step 4 that there is a comment and there is attachment. So the comment is expected 10 and got 200. That's quite a bug for a calculator. And the attachment contains the screenshot. So every step may include attachments and comments. And here is the screenshot. So it definitely wasn't a subtraction, most likely it was multiplication. So perhaps it's a copy-paste problem. When the code from multiplication was copied over to subtraction. And here is a link to a video. Each link points to the same video, just to a different timeline. So here we go. We are right on the right on time on that video, and each time you click the video, it's about 1 second after what you want to see. So you see the quality assurance specialist filling out the bug already. It wasn't the moment he pressed the button, but in this particular case, that moment definitely doesn't matter. So just below you see the diagnostic data, and these are the files that contain all the information that you need. You may notice that first two files, the adapter is called actions, and this is just a list of actions that was performed. The difference between first two files is that first is a txt file, the ordinary text file, and the second is HTML file, so perhaps better for your eyes. But in case you have some sort of automation tied to that action log, then perhaps text would be better. I personally know people who prefer to read text files instead of HTML. So the same information, just different design. Next we are going to look at system information. It's a normal XML file. It contains information such as your operating system, including the service pack, your processor, and so on and so on, and how much memory you had. So for example, you can see that the memory load is 94%. For some application this could be an issue. The available physical memory is just 110 megabytes. The screen resolution and the depth, the colors depth, and the information about the version of Internet Explorer. And each component has a key error, which states whether there was an error with that component. So we didn't have any error in that component. And the last link was to video, Windows Media Video file. And here we have the same information that we had in that XML file. The same memory load of 94%. And now, in order to look at the IntelliTrace, we have to load that project, that calculator project. Now that it's loaded, we can take a look at the last file that we didn't look yet, the IntelliTrace file. And perhaps it will be the most important file to record during the testing. Here we go. Just click it. And take a look. We have two threads with timeline. and we are just connecting to one of them. So we have one of them highlighted, and we click Start Debugging. So the application was finished a long time ago in a very distant computer. And now we have take a look at the right part. There are steps that were taken, and here we may have contents of all the local variables. It looks pretty much the same as a normal debugging, and you can go to any other step and see how the code was going. If you hover over the variables, you will see their values, and it's absolutely like you are debugging the living system, except that you don't. And as you can see, the subtract button click in the screen, which should subtract, actually it was multiplying, so that was the copy-paste problem. As you may notice, the multiply button click is doing exactly the same. It's multiplying values, while the divide button is dividing, and so on. So we need to change that code to a normal one. In this particular case, we don't need to go into the into the variables. We only need to change the code. But also we will create a test. So as you can see, we already have the test project, my math test, and we are going to add to that project a new file which will test the multiplication. It's a good practice to create a test for functionality, not for you know, one file per class. But it's totally up to you, definitely. For some reason, the UI of Visual Studio doesn't want to let me through. So we already have the existing action recording from that test in TFS. So we will use this option to use an existing action recording. We'll find a test case for it. It's multiplication tests. As you can see, it already has all the tests, all the steps. It opens the calculator, it enters the values, and clicks the multiply, and then closes the calculator. And as you may notice, it takes all the data from the test case. So there is a tag data source, which allows you to take the data dynamically instead of entering them in your code. There is definitely not much sense in putting all the values inside of your code when you can do it dynamically. So we'll rename this function to multiplication test method. Let's try and build it to see whether it builds. Yes, it does. Well, let's try to run this test. Since it's UI test, it runs the application and does everything that it needs. Okay, so seems like all tests are passed. And now we are going to generate the code for this test. Perhaps you already remember this functionality of the coded UI test builder. We just dragged and dropped the target to the text field, and we need to insert assertion that this text, the text property of this object, is exactly what we need. So in this case we are entering that it's equal to 100 if value 1 is 10 and value 2 is 10. However, this assertion will be dynamic in the code. So as I said before, the data is taken from the test case, and in this particular case, when we are adding the new code to that test, to that UI test, of course we are using real numbers, 10, 10 and 100, but we will change it to dynamic data a bit later. So we'll call it the assert multiplication method. Here it is. You may notice that the code is automatically generated. And what we are doing here, we are taking the result also from the test case. So the expected value is not 100 now, but it's the expected result from the test case. So it will not always test whether we can multiply 10 and 10, but we will be able to test it with other values. So the only thing we have to do now is to run all these tests. It doesn't matter whether we highlight them or not. Just click run and they will be run. So as you may notice, it didn't try 10 and 10, it tried different values. So all tests are passed. Five, 5, 25, exactly. 3, 3, 9. 1, 10, 10. Exactly, that's multiplication. I can tell it from my head. So that's like it. In this little demonstration we found out how to insert assertion into our automated UI tests, and what to do with bugs, how to work with bugs automatically created by Team Foundation server. And I hope that added some ideas to you if you are going to create test automation in your project. Next time I hope we will talk about the Team Foundation Server 11 and the Test Manager 11, which I think is the next big product by Microsoft that will be released in 2012. However, by all tests that I ran with TFS 11 and the Test Manager and Visual Studio 11, and they all are going to be released at the same time, I noticed that there is no big difference, at least in Test Manager, so this course is still relevant. Also, you may notice that parts 5, 6 and 7 of this course are not released yet by the time that you see this 8 part. It's mainly because part 5 is about architecture, and well, you see that little menu architecture between the tools and set and test. It's one of the least used functionalities of Microsoft Visual Studio, mainly because of the licensing and because not everyone is the architect. So I tried to release the more interesting part first. Also, although this course is like completed, except for the architectural parts, still I'm going to recreate the course about the quality assurance, working with Test Manager and automation of tests with Team Foundation servers. So if you want to be notified about it, just subscribe to this channel or to the blog, up to you. So thank you for viewing and for spending your time on this walkthrough. If you have any question, because sometimes my explanation is a bit sloppy, feel free to ask in comments, either in YouTube or in blog, it's up to you. Still, I'm very happy to answer all questions, and hopefully I will be able to answer your questions too. So thank you, and have a good time.